Let us assume root 2 be a rational number. Rational number. We are proving root 2 is an irrational number. That root 2 is an irrational number using the method of contradiction. For that, we first assume that root 2 is as a rational number. Then we prove that it is wrong, our assumption is wrong. Then that way we show that root 2 is an irrational number. So first assume the statement root 2 be a rational number. So any rational number can be written of the form root 2 is equal to p by q, where p and q are integers and also p and q have no common factors. No common factors. See, this part is important. P and Q have no common factors other than 1. Other than 1. Clear? Therefore, P is equal to, P can be written as root 2Q. If you square the equation on both sides, you get P square is equal to root 2Q whole square. Squaring both the right hand side, left hand side and the right hand side. Then you will get P square equal to 2Q square. Call this as equation number 1. So, if P square is equal to 2 multiplied Q square multiplied by 2, which means that P square is divisible by 2. P square is divisible by 2. If P square is divisible by 2, then P is divisible by 2. Divisible by 2. Clear? So, ultimately we have P is divisible by 2. Clear? Then let's consider this statement. P is divisible by 2. So if P is divisible by 2, P can be written as 2 times some integer R, where R is an integer. Clear? If P is divisible by 2, you can write P equal to 2R. If you square the term, square both sides, you get P square is equal to 2R whole square. That is, P square is equal to 4R square. Call this as equation number 1. Equation number 2. If you compare 1 and 2, you will get 2Q square is equal to 4R square. Or Q square is equal to 2R square. Call this as equation number 3. And this indicates that Q square is divisible by 2. Also, if Q square is divisible by 2, then Q is divisible by 2. See, now look at the two statements. P is divisible by 2. Also, Q is divisible by 2. So, which means P and Q have a common factor 2, which is other than 1. So, P and Q have a common factor of 2. So, our statement is like this. P root 2 equal to P by Q, where P and Q has no common factors other than 1. So, we proved our statement is wrong. If our statement is wrong, our statement is root 2 is rational. So, definitely root 2 is irrational. Irrational. So, by method of contradiction, root 2 is irrational. Clear?